Hello, everyone from South Carolina. Really wish I could be there. Like Wild West Hackin Fest is my absolute favorite conference, and had some personal come up where I couldn't make it because I have to be somewhere tomorrow. And luckily, they were able to make this happen, so I'm still able to share what I've put together with you, which is fantastic. And I'm super excited to see that so many people showed up. Like I see a lot of full seats there, which is great. See some familiar backs of heads and occasionally front of heads, so that's awesome as well. But yeah, sorry I can't be there. Glad that I still get to participate, and I will be with you spiritually throughout the day or throughout the week, and as you enjoy all the wonderful stuff that Wild West Hackin' Fest has to offer. Okay, but without further ado, I'm gonna go ahead and share my screen, and we'll dive right into the content because I got a lot to talk about. All right, here we go. So what are we talking about here? We're going to talk about web application authorization, what I like to call the perfect storm. And I'm going to teach us or talk to us about how we're going to go about taming that perfect storm. Okay. Like I said, I got a lot of content to go through, not a whole lot of time. So I want to spend as little time as possible talking about me. But what I will say is everything you see on this particular slide right here, I do for God's glory, my joy, and the world's good. And so if you have any questions about that, got any questions about the stuff that you see on the slide right here, by all means, hit me up in the Discord and I will expand on that stuff. And then of course, if there's any questions from the talk, we'll also cover those there as well. It's great that we have that persistent connection there in Discord that allows us to continue to have these conversations after the fact, especially since I cannot be there. Okay. All right, so here's the outline of what we're going to talk about today. The first thing we're going to do is define what the perfect storm is. Then the bulk of the talk will be talking about how we're going to go about taming this perfect storm. And then at the very end, we'll give some tips for how to prevent the perfect storm in the first place so that we don't have to tame it. Okay. That's basically the general outline of what we're going to do. And everything, the premise for this entire talk comes down to this particular slide right here. So the OWASP top 10 for 2021, the top vulnerability on the OWASP top 10 was broken access controls. Now my connections within OWASP tell me that when the 2025 list comes out, which I believe should happen in the next week or two, like the first week of November is when they're going to come out with the draft list. This will probably be on top again. Why? Because it's the most easily missed yet essential to find vulnerability. I believe within web application security. One, it's most easily missed because tools don't do it, and testers aren't particularly good at finding them. We don't have a lot of manual tools that help us do this. It's some of the stuff that we're going to talk about here today and try to solve that problem. But it's essential to find because if you find one of these vulnerabilities, quite often it's a privilege escalation, which is a really high severity type of issue. Now, what really drove me to talk about this on a larger scale than just teaching it in some of the classes that I teach is the fact that when I left PracticeSec to go back to work at OnDefend earlier this year, I had been running my own company and conducting assessments for 8 years, just back to back to back 8 years. And I went over the last 40 assessments that I conducted as PracticeSec and found that I had found 41 authorization findings within 40 assessments. Now, I'm not a math genius, but if I'm correct, that's a little over one authorization vulnerability per assessment that I conducted for my last 40 assessments. So what it really comes down to is if you're not finding them on your assessments, it's not because they're not there. It's a really high likelihood that you're just missing them, right? And that's what this talk is about, to prevent us from missing these things any longer. But why are they missed? Well, because access control systems are just hard. If you've ever built one yourself, or if you've ever been on a development team or built an application where you had to implement one, then you know that they're difficult to design, they're difficult to implement, and they're difficult to maintain, right? And that's all on the developer side. That's their burden to bear, but it is hard to do. And then on our side, the tester side, they're also difficult to test. As I mentioned, automated tools cannot find these things because they don't have the human context, right? They can go and look at a document, but they don't know whether they're looking at a document that belongs to me, the current user they're logged in as, or if it belongs to Brian, which is not the current user they're logged in as. They just know they're seeing a document. Same thing goes with vertical authorization issues. It may run and accidentally find its way into an administrative part of an application, but it doesn't know to report that as being a problem because it's just operating on behalf of the credentials that you gave it. So our scanners and our automated tools, they may very well exploit or discover unknowingly authorization issues. They don't even know to tell us. So they're hard to test because our tools don't understand them very well. And I think a lot of testers, because they haven't designed, implemented, and maintained access control systems before, they don't have a good enough understanding of them to really find them. And so that's the main problem that we're trying to solve here. But that's why access control systems are hard. Okay. So that's more defining the problem. Now let's move into the bulk of what we're going to talk about here, which is solving that problem, right? Taming this storm. And the way that I do it is a three-step process. Now, this three-step process for how I discover authorization issues spans across the web application testing methodology. So you see here three different steps of the web app testing methodology. And these things they're not necessarily contiguous, right? These are just three different steps. If you break it all down into a larger methodology, these are three steps in it: mapping, content discovery, and vulnerability discovery. But within those phases of the methodology, that's when I will conduct these individual steps. And so basically what I've done is I've extracted out just the authorization testing piece from the larger testing process, and that's what we've mapped here. So within the mapping phase of the methodology, that's when I'm going to identify the architectural design pattern of the application, because that's going to indicate to us how we would go about, or some additional techniques that we would have when we go about finding authorization issues or access control issues. Then when I'm in the content discovery portion of my methodology, that's when I want to discover all available routes, because you have to know routes before you can test them for authorization issue. And then finally, when I'm in the vulnerability discovery portion of the methodology, that's when I'm going to apply the appropriate technique based on the previous two steps to determine whether or not access controls are properly applied across the entirety of the attack surface. So this is the high-level process that we're going to cover, and we're going to break down each of these steps and go through some techniques for how I go about doing that and how I recommend you go about doing that as well. And we're going to start off with identifying the architectural design pattern. And this is really important because the design pattern used to create the application will indicate to us what techniques that we can use, or some additional techniques that we can use in some of the follow-on steps of this process. Now, there are quite a few design patterns out there, architectural design patterns for web applications, but the most prominent one for the past 15, 20 years is model view controller. Okay. And so that's the one that we're going to focus on. The vast majority of the apps that you run into should be model view controller. Out of those 40 apps, I would venture to say maybe one or two of them weren't. Okay. So in the interest of time, that's what we're going to focus on is MVC. And there are also other versions of MVC or flavors that have small adjustments that you might run into. But talking about this particular architectural design pattern here will inform how to approach those other derivatives of this as well. Okay, so this is the most popular design pattern application development today, has been for quite a while. And the reason why it's popular is because it separates the application from a development perspective into three different pieces. You have the model, which is the internal representation of data, the view, which is basically the user interface, and then you have the controller, which handles all of the requests, routing, and the business logic that is being executed for a particular request. Okay. And you can have different developments or different developers or development teams working on each of those pieces. And so you can have developers that are just focused on the model, developers that are just focused on the view, and developers that are just focused on the controllers. And this provides a lot of different advantages. Like I have a whole slide of advantages that I could have put in here, but it's a little bit out of scope, it takes up a lot of time to talk about, but there are a tremendous number of advantages here. But there are also some disadvantages. And those disadvantages are largely what we're going to talk about within the context of access control. But non-MVC patterns, what they generally have done is combine all of these pieces into one, which became difficult for all of the advantage that you get with MVC are removed when you do that, which is why we've seen the move from these older patterns where everything was combined in a single file, both the interface, business logic, and the data stuff, to move them into separate components. So that's model view control at a very high level, but there's two versions of model view control that we want to cover. Okay, and the first one here is server-side rendered MVC. So just a little bit of foreshadowing, server-side rendered MVC and client-side rendered MVC are the two design patterns that you're going to see vast majority of the time when you're testing applications, and those are the two that we're going to cover here. So to quickly walk you through server-side MVC and why it matters, we'll just start with the flow here. So when a client makes a request, and if you look at that dotted line in the middle, that's kind of the separator between what we have, the client side and the server side. So when a client makes a request to an MVC application. It gets routed through a router that then basically the router just selects which controller or which function is going to process that request. And it routes based on the structure of the URL. So a URL, whatever it's supposed to look like, the developer establishes a route table that says, hey, when a URL looks like this, I want you to process that request by this function. And that function is called the controller. So then the controller here is executing business logic. And as it does so, it may need to interact with the data store. And if it does, then it's interacting with the model. And then once the business logic is complete, it will then pass whatever information is necessary over to the view, where the view will build the HTML, the user interface, and respond that back to the client, where it gets presented to them within the browser. Now, in those old architectural design patterns, none of these pieces existed. It was basically just a file on the file system. So there didn't need to be a route, because a file system, it's already a set location. So it would just make a direct request to that file. The web server would host up that file from the file system, and basically all of these individual components would be in that one file. So like access controls only had to be done in one place. You do it at the top of that one particular file, and it applies to the entire rest of the process. Well, here we have three different sets of developers that all need to consider access controls. The controller developer needs to consider access controls for whether or not the current user should be able to execute what this business logic's trying to do. If it's trying to access data, well, then whoever's developing on the model needs to check access controls to make sure the object that's being accessed should be accessible to the current user. And then the view developer, right? They've got to know they've got to apply access control so that they're presenting the proper interface to the current user, whether they're unauthenticated, whether they're a basic user, whether they're an administrator, and so on and so forth. So now we've got access controls that need to be applied on the controller, model, and the view. At a minimum, the controller and the view, because not always is there a data store involved there. But that's three different places that access controls need to be done. And so when we're testing for authorization issues, those are some of the test cases that we need to think about. Well, what if they're applying access controls on the controller, but not the view? What if they're applying access controls on the view, but not the controller? And vice versa between the model and the controller as well. And as the attacker, we're the client. We have very little control over that, other than the route that we request and the session that we send in with it, or the token that we send in with that particular request. So we have very little control over the process, but we still can do some things here in order to run through those test cases. And obviously that's what we're going to do moving forward. But that's what we're looking at when we're dealing with server-side rendered MVC. Now, the other side of this is client-side rendered MVC. And if you've heard the acronyms SPA or SPA, or whatever you want to call it, single page application is what that stands for. That is a client-side rendered application. So feel free in this particular context to use these terms interchangeably. But notice that it's very similar. All the same components exist, except with client-side rendered MVC, the view has now shifted from the server side over to the client side. And so now this is interesting, because when we're looking at server-side rendered MVC, the view is over on the server side, and we have full knowledge of everything that's going on right here, including the current user. So the view easily knows the current user because it's based on the request that came in. Controller, model, everything does, because once again, this is all operating in the same context. But now with the view operating on the client context, when the controller passes things over to the view, it also has to tell it which view to create, right? Which view to draw. And the only way it can do that is by passing some sort of information over that says, this is a basic user, this is an admin, this is an unauthenticated user, so on and so forth. And because we are on the left side of this diagram along with the view, we will have control over that process. So the test cases remain the same. All access controls still need to be applied in all three of these places. But when a client-side rendered application, we have a lot more influence over how that works on the view. And that's something that we're going to take advantage of. Okay. So that's the importance of the architectural design patterns. And once we've established that, now we've got an idea of some things that we're going to be able to do at these other levels. And now we're going to move into step two, where we start to take advantage of what we know about the architectural design pattern and continue to collect the information we need to test for access controls. And so the second step here is discovering all available routes. Or we can't test a route for access controls unless we know that a route actually exists. So our goal is to discover all available routes. Okay. And so the first way that that's going to happen here is through using credentials. All right, using credentials. This is the simplest method, obviously, right? You have a username and password, you log in, you map the entire application with that particular account, and now you have all routes that are associated with that particular application. Now, this is obviously not practical for all test types. If you're doing true red teaming, if you're doing true pen testing, you probably do not have credentials, which means you're going to need to use one of the other techniques that we're going to talk about. But if you do have credentials, this is the easiest way to go about populating or discovering all potential routes. And notice here I say multiple credentials at every target role. So multiple credentials, what that does for you is it gives you the ability to test for lateral access controls, right? If you have multiple accounts at each role level, then you can test for lateral access controls. That's a little outside the scope of what we're talking about here, but it's important to ask for at the same time, because this is where, if you were scoping, these are the questions you would want to ask. But you also want to ask for every target role, because that's where you are able to test for vertical access control. If there's an admin, get an admin account. If there's a basic user and you can create one, make sure you create one. If not, make sure you get one. And then of course, unauthenticated is always going to be a role that you test as well. All right, so multiple credentials, every target role. And then what you do with those is you fully map the attack surface at every role. And what that's going to do is give you a complete list of all routes that the application is designed to expose by the developer. This is how I populated the demo project that we're going to use when we go into the demos a little bit later on in the talk. Okay, so credentials is the first way that we can do route discovery. All right, the second way that we can do route discovery is client-side source code analysis. This is specific only to client-side rendered applications or single-page applications. Again, that's why it's really helpful to know the architectural design pattern, because now we would know whether or not this is even a valid technique to apply. And there's 4 different ways I go about doing this. The first one, and they're in levels of complexity, being most complex at the top and the least complex at the bottom. Okay. And so we won't demo the first one because it's the most complex, but basically if you have generally a good understanding of the client side framework, okay, then you might be able to go in and look at the client side code, which is running in your browser, and it's going to be inside of Burp Suite Pro. If you're using Burp as your interception proxy or whatever you're using for an interception proxy, it's going to be there. Okay. So then you go in there, and if you have an understanding of it, you find the route table for that particular client side framework. And then you would find the route table, trace the routes down to the individual components that populate the interface. And then within those individual components, you will find the functionality that's associated with buttons and clicks and links and all of that. And those are going to typically have within the code for those particular events, you're going to have URLs to the back end. And so you could harvest them just by following the route table back to the individual components and then pulling out the different backend calls that are happening within those components. Now, one of the cool thing about client-side rendered applications is the vast majority of the time, in fact, I don't think I've ever tested an application that wasn't like this, is all the routes for all of the roles are going to be in the front side code. The client side code. The difference is you just won't see them in your interface. But if you go looking in the source code, they're there, right? So you can enumerate all the routes for every single role going back to the server side from the client. You just have to do the source code analysis to do that. One of the ways we can do that is by following the route table within the client. Now, some easier, more practical ways to do this. Number one would be to search for request calls by library or object, or search for request calls by method. And so fetch is a API built into JavaScript for making calls from the front end to the back end. So look in the code base or anywhere that's being used, and that's going to lead you to back end API calls. Axios is also a very common library that's used for this. And so just look for Axios dot somewhere in the front end, and that may lead you in that direction. And then if maybe you do search for those and you don't find anything, then maybe they're using another library. And most libraries do use a similar convention where if they're making front end calls, they use the method as a function. So .post or .get, and searching for those things within the JavaScript may lead you right to where or should and will lead you right to where those backend calls are being made. You record those routes and you keep looking. And so I was going to demo this really quick just to show you how I would go about doing this. So if I go over to Burp, which has my full target sitemap, there's a couple different places you can get to search, but Burp search is what we're going to be using here. You could select the magnifying glass, you could go to Burp search, or you can just right click on a target and go to engagement tools search. So there's a lot of different ways to get there. But once you're there and you're in the search interface, then you can just search for fetch, parentheses, and then of course I want to stay in scope with this. It's not regular expressions. I'm also only interested in response bodies because this is going to be inside of JavaScript content. And then I'll just limit it to what I'm seeing in my proxy and my target. Hit go. And it did not find it. Did I do something? Maybe I didn't add it to scope. Let's look. Um, Love the live demos, huh? It should be finding this. Not sure why it's not. Okay, well, we're going to skip that one then because it should totally be finding that, but I don't want to spend too much time on that anyway. Okay, I was actually going to skip over that one initially, but you get the drift. Search for fetch, search for Axios, and then if they're like wrapping fetch or something like that, and some other object that they've created, you'll still be able to trace that back to where the actual API calls are being made, and then you'd be able to go from there. I'm actually like gonna walk down this path because it bothers me that I wasn't able to show it to you. Actually, I know why. I was looking in the wrong spot. So let's do this again. Let's search for test.onweb.com because that's our single page application. I was actually searching in the server-side rendered application. So this will be what we're looking for. Yeah. So you can see here that it did find the call to fetch, and it found it in fetch-wrapper.js. And if we look at the source code here, we can see the call to fetch. And we don't necessarily see any API calls here, but we do see it's creating a function called request that's being used within this thing called fetch wrapper for .gets, .posts, .puts, and .patches. So what we're really looking for here is fetch wrapper dot one of these things. And so let's look for that. And we have a file called services API.js. And when we look at that, we see many uses of fetch wrapper.post, .delete, .get, .post. We see them being used inside of objects called access token and user and admin. And we can see that this is clearly the server-side routes for all of these different resources. Okay, so this is a common design pattern for developers to put all of their API calls in a single place and then call them from within the application where they need to. And so if you're lucky, like we are in this particular case, and the developers use this particular practice, all of your server-side routes are in a single file. You can parse those out of there, and now you have full knowledge of the route table for or the server-side routes for this particular client-side application, client-side render application. So if you're comfortable looking at code, this is really powerful stuff that you can use here. If you're not comfortable looking at code at all, then you just want to look through the client-side code for anything that even resembles a URL. You could use regex searching and use it in the search tool like we just did, or you could use extensions like JS Link Finder, which is a Burp application. It's built into Burp. You could install that, and what it does, it's like a passive analyzing tool that just looks for anything that resembles a URL and puts it in a list for you so that you can go back and analyze any URLs that were embedded in the client-side code. There's definitely going to be some false positives here. It's going to be pretty ugly, but if you don't like looking through code, you don't feel comfortable searching through the JavaScript, this is a really good way to do it as well. Okay, so credentials, client-side code analysis, and then finally, our last stop, the last option we have is fuzzing. Okay, fuzzing. Now, most of you have probably heard of tools like Dirbuster, Derby, GoBuster, Fuff, and other type of content discovery fuzzing tools. All right, these are all fine. They all do well. If you use those, that's okay. But what most people don't realize is Burp actually has one built inside of it already, and it's called Discover Content. So let me show you where this is at. So if I'm in Burp and let's say I want to do some brute force content discovery on www.owntub.com, you can right click on it and then go to engagement tools. And within your engagement tools is discover content. And so if we click this, right, you'll see this is actually the same kind of thing as all of those other tools, except now it's built into Burp. And since it's built into Burp, it has some advantages. Number one, it does create its own sitemap within the tool itself, but anything it discovers it will also add to burp's sitemap so that you don't have to take the output from one of these other one of these other tools and figure out how to get it in there. It will already be in there. The other thing that it does is it will take, and these two checkboxes right here allude to this, it will take files and folders in the current application and the current sitemap, and it will add those things to the word list. And then it will use those as well. It'll add that to your current list because it has context of what the application currently contains. And it will also, what Burp will do is it will identify patterns in certain names of files and folders. And if it identifies a pattern, then it will try to attempt variations of that pattern in order to find other things like, spring 1980, and it'll try fall 1980, or spring 1980, in my file, try spring 1981, just weird patterns there. So it will do some of that as well, but it can only do that because it's built into Burp already. But otherwise, it's got the features you would expect. You can fuzz for files and directories, or files or directories only. You can have it recurse if you want it to automatically recurse. Of course, you can use built-in list or select your own for files and directories. You have the ability to highly customize the extensions that you would use if you're testing an application that uses file extensions. If you do an MVC, and that which causes the last part of the URL to not have a file extension, then you can still test the file portion of the URL with no extension. So that option is there as well. And so it's got all the same feature set, but I just like to show this to folks because they don't really realize it exists or maybe never stumbled upon it, but it's built into the tool that you already use. So you might as well leverage it. Again, if you really enjoy some of these other fuzzing tools, that's totally fine. Just understand that discover content is there, and it's certainly helpful. Now, the thing to be aware of for all these particular tools is the way they do the recursion, right? These tools, all of them, and this is not just discover content, this is everyone listed on here, was designed based on the idea that web applications map to a file system structure. So all the URLs would be hierarchical. You would not have admin users without /admin being there. Well, that would fail with an MVC application, which again is majority of the applications that we test, unless the developer explicitly built their routes to be hierarchical. In an MVC application, a developer can say, I want to have admin users as a route, but I'm not going to have anything at /admin. Well, you'll never find that with any of these tools because it'll never recurse to admin users because you never hit something on admin first. So always be aware of how recursion works when you're dealing with these fuzzing tools, because most of these purpose-built fuzzing tools will not recurse unless they find something at that previous point. And that's not how MVC applications routing work, okay? At least not intentionally. Developers can build routes however they want to. They can make the URL as custom as they want it to be. If that's the case, then your application is doing that, then you probably want to fuzz using a more custom fuzzer like Burp Intruder, which will give you the ability to customize it to recurse whether or not it finds something. Now, the downside to using something like Burp Intruder is you will have to do all the analysis, right? You're going to have to do all the analysis. You'll have to do all the analysis. It's going to take a lot longer simply because you're forcing this recursion, which could take a very long time and result in nothing, but it is an option that you have. Regardless of which technique you use to do the fuzzing, you're only going to be as successful. Your level of success is going to be mapped to how good your word list is. Don't use a word list of usernames and passwords to try to guess files and directories, right? That's just not going to work. So some lists I like are any of the Digger lists, because what they've done is they've crawled open source code repositories and built lists out of files and folders that exist there. And then the robots disallowed and wrapped lists, they crawled the X number of the Alexa top 1 million websites, parsed all of the files and folders out of the robots.txt files and built lists out of those. So two really good techniques for building word lists designed for this type of fuzzing. Okay, but that's our last option. When the first two aren't available to us, this is the last option that we have for route discovery. But at this point in time, once you've done with a multiple or at least one of these three things, you probably have the best idea of the attack surface that you're going to have. And so now we're ready to move into the final step, which is actually determining if any of these routes that we discovered are missing access controls. Okay, so that's what we're going to do next. Apply the appropriate technique. And there's multiple ways we can go about this as well. And also, once again, we're going to see that the architectural design pattern does have an impact here too. So the first one is manual forced browsing. Okay, this is where you would go through and manually invoke every known resource from a particular context. So if you have a bunch of GET requests that are unique to logged in users, then from an unauthenticated perspective, you would literally go into the URL and try to navigate to them. You would force browse to them. And if it was post request or put request or anything like that, you would have to use a replay tool like Repeater, send it over to Repeater, remove the session or overplay the session with a different one from a different user context, hit send and analyze the response. It's an extremely manual process. You would have to do it for every user context and for every resource that you discovered. Do not do this, okay? We have tools that will do this for us. This is maybe something we had to do 20, 15, 20 years ago. We don't need to do this anymore. There's way better ways to do this. If this is the way you're currently testing for authorization, not anymore, not after today, okay? This is an option. I highly do not recommend this unless it's absolutely mandatory. If for whatever reason you can't get your tool to operate within context, that's the only time that you would need to do this. But I've never ran into that scenario, so I don't believe that you will either. So let's dive right into the second technique then. And this is UI privilege escalation. And this blew my mind when I first realized that this could happen. And I don't think that it was something I ever would have stumbled upon if I didn't actually write client-side rendered applications for myself. This is a technique that's only valid for client-side rendered applications. Um, and uh, and so, yeah, so basically what it comes down to, if you remember the diagram that I showed you, now that the view's been moved over to the client, at some point in time, the server, the controller on the server, has to tell the view on the client what's the current user that's logged in so I can create the proper interface for them. So I can show them the right menu items, show them the right feature set and functionality. And there's a bunch of ways that an application can do this. It can do this by passing over a user object, where it just after, when it authenticates, a user object that gets passed to the client that says, this is the current user that's logged in based on your token or session, and this is their role. You can do it that way. I've seen permissions object where after the user logs in, the server sends over a large list of permissions that are associated with client-side components and features. And so that's how it knows what to do. I've seen a permissions map where both the client and the server are already aware of all of the permissions, and the server just sends over basically a list of true, false Boolean values. And then this client side basically maps that Boolean list on top of the permissions list and knows which permissions the user is supposed to have. I've seen that done. And then I've seen it where basically the server just sends over a list of components that particular front end components that particular user is allowed to access. So it's kind of similar to the permissions object, but it's actually referring to components at a more lower level rather than permissions. So I've seen it done that way. Basically, this has to happen, and a developer can do it any way they want to. These are just the four ways that I've seen it done more than any other. In fact, this probably encompasses every way that I've seen it done. Has been one of these four. Not that it couldn't be done a different way, but these are the ways that I've seen it. And this is going to happen right at authentication or just after authentication. That's when this is going to happen. Okay. And so what do we want to do then? Well, since remember I said that we now have a lot more control over this process because we're that man in the middle on that dotted line, and we're going to see that information come from the server to the client. It's exactly what we're going to do. We're going to manipulate the current user's permissions by modifying that exchange. And then once we do that, we'll be able to see the interface as a different role with our current session. We'll be able to see that interface as a different role and then navigate through it to determine whether or not we're able to do anything that we should not be able to do. And there's a couple different ways within Burp that we can do that. So the first one here is going to be intercepting and modifying. Okay, so let's go back over here to Burp. And I'm going to initiate, actually, we're going to go to OwnTub 2.0 first. I'm going to initiate the authentication process for this application and then intercept it and show you how we would do this. Now, I'm currently logged in as a regular user. Notice that there's a notes page, a scans page, a messaging, these are views, not pages. So a notes view, scans view, messaging view, and there's a profile view, and then there's a log out button here, which is going to log me out. That's fine. I want to do that, but I wanted you to see what it looked like to be logged in as a normal user first. So I'm going to log out here, and then I'm going to go through the authentication process, which in this particular case is passwordless. So it sends a code, which I'm sure many of you have seen this before. I'm going to go ahead and copy this out of my fake webmail setup I've got here. And before I submit this, because this is the final step of the authentication process, I want to now go and start intercepting because I want to see the exchange here and then modify the thing that is obvious, it's going to be pretty obvious, modify that thing that's telling the client which interface to build. And so I'll go over to proxy, intercept, we'll turn this on, and we'll send this through. Okay, so now I'm intercepted. I see that anytime you see options, this is going to be cores, basically core stuff happening here. I'm just going to forward that through so we can ignore the options there. Ignore the other, this is the response to it. Now here's my post. This is where I'm posting the code and the code token. So this is that final step of authentication. I see my response come back through, and it's just an access token here. So I'm not seeing a user object or any of those things that we just talked about. I'm just seeing the access token that belongs to the currently authenticated user, which in our case right now is a basic user. So I'm going to continue to forward this and watch the flow. And then I see another CORS. It's asking for permission to users.me. That's fine. We'll let that go through. We'll get through the options. Now it's the actual GET request to users/me with the new access token that I just retrieved. And the response is going to be a user object. So this is that user object that we were talking about. This is the server telling the client, this is who's currently logged in. This is the interface this is the person you should be building the interface for. And here we see role equals user. So this is likely what the front end is using. So we could just modify this. And a really quick guess on this would be like, hey, what happens if I check admin or super user or root or any of those things? So we'll go ahead and modify it here in the interception. And you already saw what it looked like when I was logged in as a basic user. And we'll let this go through and see what happens on the front end. And we can see here that we have been logged in as apparently an administrator because I am now looking at the users management panel, and I now have a tools management panel as well. The note-taking view and the scan view has gone away at this point in time. So I'm clearly logged in. I'm clearly seeing what the administrator should see, right? But I'm still logged in as me. Okay, so I'm using my token, but seeing what the administrator would see. And now what we do is we just go in and figure out whether or not we can do any of these things that's now exposed to us. So we would try to maybe promote and demote a user. I can't do that. It's telling me I'm not allowed. It's probably getting a 403 back from the API. Same thing with enabling and disabling. Okay, things seem to be safe there. Now let's go over to tools. Let's see if I can add a tool. Nope, won't let me add a tool. What about delete a tool? Can't delete a tool either, okay? So the very obvious things that seem to be associated with the administrator level of access, I can't do. So access control, this is, by the way, this is not a vulnerability. This is how single page and client-side rendered applications work. So we're not breaking anything here. We're just doing what the application allows us to do. This is inherently possible with every client-side rendered application because it has to be this way. It's one of the concessions that a developer has to make when they choose this architectural design pattern. Okay, the real vulnerability would come in if we could do any of these things, but we've not been able to do any of these things, and that's okay. But I will call your attention to one thing. The simple fact that we're seeing all of this information about each user is the potential sign of an all access control issue. Because as a basic user, which I'm currently logged in as, even if I could invoke this particular client-side route, it should not actually, the API request, which populates all this data, shouldn't work. I shouldn't see people's email addresses. I shouldn't see people's roles or their user status, right? Maybe their display name, but none of this stuff. So we actually have identified an access control issue. If we go over to Burp and we look at that get to users, this particular request and response right here should not have been accessible from my basic user token because it included all of this sensitive information within it. So they either are responding with too much data, which is an information disclosure issue, or this whole endpoint right here should not be accessible to a basic user. And that's probably the case here because as a basic user, there's no interface where you need to pull down user data for every single user. And so I would say that that's likely what the problem is here. But just by changing our perspective of the user interface, we were able to identify a potential access control issue here. So there's a couple other ways that we could do that, right? This intercept and modify is easily weaponized with match and replace, right? Has anybody ever done the match and replace rule where you find every instance of false and replace it with true? It will horribly break an application, but it's pretty funny to see that play out. And you might actually unlock some pretty interesting stuff. So that kind of thing. But here you're literally explicitly looking at role equals user, change it to role equals admin. Every time you log in with a basic user, you're going to see that admin interface. So you could use match and replace. You could also do it through manipulation on the client. So or storage manipulation or DOM manipulation. And I'll very quickly show this because I am getting a little short on time here. So if we go into local storage, I'm trying to see where's my developer tools here. We have local storage and session storage. Find out where it's storing those tokens on the client side, or that information on the client side, because if this application is going to survive a refresh, this stuff has to be stored somewhere in the client. And that's either going to be in session storage or local storage. If they want it to survive a browser shutdown, it's going to be in local storage. If they want it to survive a refresh, it'll be in session storage. But notice here, you can see that information right here. You could just change the user information right inside of storage, refresh the page, and then now we're seeing notes and scans again versus all of that other stuff. The other way you could do it, if you're really into digging into the client side active state, is just do it right inside of the active state. So we'll do pinya.getActivePinya, which is a client-side state management library for Vue.js applications. So we go to state.value, let's go to auth. User info, I think, is where this is stored. Yep. And then I think we have a role in here. We do. So notice how role is user. I can just set the role item in the state to admin, and then watch what happens in the user interface up here right when I hit enter. Since client-side applications are reactive, it's reacting to the state. It's going to instantly update the second I hit this. Hit enter, boom, and you see I'm already users tools again. Okay, so you could do it within the console as well if you're familiar with the framework and know how to navigate the application's client-side state also. So pretty cool stuff. This is awesome. And this is a big deal here. Being able to do that makes it really, really easy to find access control issues within client-side rendered applications. Okay, now the final discovery technique here is just using the tools that are available to us. And we've got two good ones that are available to us. Compare sitemaps, which is a built-in tool that I've found that hardly anybody knows about. And then there's some extensions like Auth Analyzer, Authorize, and Auth Matrix. Now, I've looked at all three of these. They all provide a similar feature set and a similar approach to how they find authorization issues. Auth Analyzer is way better than the other two, in my opinion. I still prefer Compare Sitemaps. So I'll go through the demo of both of these and show you how I use them. But if you want to use an extension, Auth Analyzer is by far the best of those three options that you see before you. There may be some other options out there as well that I'm not aware of, but these are the three that I've explicitly tested. Now, let's go over here and demo this compare sitemaps thing, because a lot of folks don't even know that this exists. On your target tab, if you right-click any of your targets here or anything in the sitemap, it's not in engagement tools, because you normally think that this is where most of our tools in the context menu is at. It's actually sitting right beneath that, and it's called Compare Sitemaps. It's just sitting there inside the context menu. And when you open it up, it leads you down a process where you get to tell Burp, there's two different sitemaps I want you to look at. Just compare them together and show me the difference. Well, when we mapped the entire attack, and that's in the case of our demo project, I had credentials. So I logged in as every user, mapped every user. So I have all known routes for every user role. That includes admin, basic user, and unauthenticated. So what this allows me to do is set the current sitemap 1, as my current Burp project, which is everything. That's my entire sitemap, the entire attack surface of the application. And then what you can do, oh, I think I just selected the wrong one there. Let me go back. Yep, use the current sitemap, okay? And then within sitemap 2, once I select these two, I'm using only selected branches because I only want to crawl this one. Otherwise, it assumes everything over there, but I only want to do the one I've selected. Okay, and then I'm also including only in scope because I've previously gone and removed the login and log out resources, because I don't want this tool to log itself in and out with current credentials that are sitting inside of the sitemap. Okay, so we're going to do this here. And then the second sitemap, this is where the secret sauce is, because you could load another sitemap from another project file, maybe a year ago. You want to see the differences between last year's and this year's. You could do that. But the secret sauce here is requesting sitemap 1 from a different session context. And so what we can do here is we can actually request sitemap 1 using whatever our browser is currently logged in as. So if we currently have our browser logged in as, and I'm going to move this over so I don't have to keep going back over there. Okay. So if our browser is unauthenticated, which it's going to be as soon as I hit log out, once again, you can see the menu here is for the regular user notes, artifacts, pwn mail messages. But if my browser context is logged out, then burp's context is logged out. So when I tell it to recrawl the sitemap with a different session context, it's going to go and request the entire sitemap within burp, but it's going to do it from whatever the current context of the browser is, which is logged out. So for our first test here, we're going to go from an unauthenticated perspective to every other authenticated perspective. So we're going to crawl the entire sitemap, which is everything, from an unauthenticated perspective. That's by logging out of the browser. So that's what we're going to do here. These other windows you could just skip through because they don't really apply in the context of what we're using this tool for. And you'll see it go through, make all the requests, and then it'll process those because it'll be comparing the responses that we just received from the recrawl to the ones that exist in our sitemap. And now what we have here, and I'm going to get rid of sitemap 1 because sitemap 1 is what I already know about. And I want to sort by URL is what I'm going to do. There's some other things I'll go in here and clean up just to make it look a little bit cleaner. Right? And then what you do is you go down to each of the resources within the application that you should not have access to and make sure that you're receiving the proper response. And so things like the home page and the about page, anybody should be able to get to, the unauthenticated user should be able to get to. So getting a 200 there is fine. Admin tools, I should not be able to go there from an unauthenticated perspective. And I'm getting a 302. We can see that the 302 is redirecting back to the login page, which is a fine response because that's telling us, okay, you're not authenticated. Let me send you back to the login page before I try to let you do this thing. And so that's what we're going to look for. And you just go down the entire list of resources and make sure that you're seeing what you're supposed to. And as you go down all of these, you'll notice that all the stuff that an authenticated user should not be able to do, such as interact with artifacts, send and receive mail, interact with the messages panel. All of those things are giving us 302s back to the login page, which they should, until we get to this right here. All of a sudden, I'm going down messages. I'm like, okay, messages page 1 is 302, 302, 302. All of a sudden, messages unfurl is a 200. That is clearly a part of this messages feature that should only be accessible from a logged in user's perspective. But I just was able to hit it and get a 200 back from an unauthenticated perspective. That's a missing access control. And it sticks out because as a user, as someone that has used this application and mapped it and interacted with it, I know that I should not have access to this from the context that I just crawled it from, which is unauthenticated. Okay. So that's how you use this tool. And so in this particular case, we did it from an unauthenticated to authenticated. If you were going to redo this in the next step, you would go back here, you would log in as your basic user, you would rerun this tool again, but then you only want to pay attention to the administrator level stuff because all this other stuff basic users should be able to do, but they should not be able to administrate users and tools. And so you would focus on those resources and make sure that you're getting the right responses there. Okay, but we're going to reserve that particular test for Auth Analyzer. So let's go ahead and now let's do that from basic user to admin. Let's do that authorization test, which would be our next test case. Let's do that with Auth Analyzer. So I've got Auth Analyzer installed here. And basically what it requires you to do is set up user sessions. So I'm going to set up a user session for a normal user. So I'm going to go in and log in. And now here within my first request in the proxy history, or any of these, like the notes, now I have my cookie. I think I want the whole header here. So I'm going to copy that. And what Auth Analyzer has you do is put the entire header to replace in here. So what this is going to do is I'm going to give it this. And what's going to happen is then I'm going to go log in with the administrator, that elevated user, and I'm going to go just click through all the stuff that I can do as an admin. And what Auth Analyzer is going to do is in parallel to that, it's going to replace the header that I send in the browser with this particular header right here and make the request again. And then it's going to show me a map down here in the lower left-hand corner of whether or not I saw the same or different responses. Anywhere those responses are the same are things that I want to pay attention to, because that means both the basic user, which is this cookie, and the administrative user, which is going to be the cookie coming from the browser that I'm about to establish, had the same response for that resource. And that's probably a bad thing when you're accessing from two different user contexts. So that's what this does. Now, what I want to do is, before I start analyzing, I need to actually kill this. I need to log out of this without killing the session. So what I'm going to do is just go into the developer tools. I don't know why my shortcut for developer tools isn't working, but we'll do it this way. Go into storage, delete all my cookies. Now I will be logged out, which I am. Perfect. Now I'm gonna log in as an admin. Now the session's still alive, the one I put in Auth Analyzer, because I didn't kill it by logging out. All right, let's get back to our administrator homepage here. So now I am logged in as the admin. I can see tools, I can see users. So now what I want to do is go ahead and start Auth Analyzer and navigate all this administrative content. So Analyzer is running. Now I want to disable and enable, or promote, demote, disable, and enable. Okay. Then I want to go over to the tools, try to add one, and delete one, which I can do, right? Because I'm an administrator. All right. So I was able to do all those things as an administrator. Now let's go look at what Auth Analyzer told us. So Auth Analyzer said for adding and removing tools, all the responses were different, which indicated to the tool that we were not able to do that from it was not able to do it from a basic user's perspective. Okay. So we might want to make sure, and we would do that by looking at the response, just like we did in compare sitemaps, to make sure that I'm not seeing that's not different in a way that still exposes that information. But here we would go down and we would see that access controls are properly being applied. Here where we see same, this is a problem, because users enable, users disable, users demote, and promote got the exact same response, whether or not I was an administrator user or a basic user. And that is a clear indicator that that is not applying the proper access control on that particular interface. Okay, on that particular controller or server-side resource. So this is how Auth Analyzer does it. Auth Analyzer is going to make you remap portions of the application over and over and over again, which is why I don't like it. With compare sitemaps, you already have your compare sitemap, right? The tool's going to do the mapping for you. You don't have to do that. So you just tell it what to do. You give it the user context. It does all the work and leaves the analysis to you. Where Auth Analyzer makes you do the work and then it does the analysis, which I think is the opposite of exercising our strengths, right? Humans are better at analysis, tools are better at automation. Let us exercise our strengths. I think compare sitemaps does a better job of that. But those are the two ways that you could go about using an access control testing tool to determine whether or not access controls are properly being applied. Okay, and that brings us through our process. So that's teaching us how we are going to go about taming the storm by discovering these problems and then recommending to developers to fix these or to plug these holes. But preventing the storm, that's really kind of our hands. Unless you're a developer in the room, this is on the developers to do these things, right? These 4 steps are something they should really be doing. Maintaining well-defined permissions models, conducting peer reviews, right? Including security stories for access controls within their agile processes. And then if they're really forward-leaning, implement security unit testing so that they can actually take those unit tests, build them into the pipeline. And now every time that application gets deployed, those access control unit tests will be ran against the application to make sure that they didn't accidentally remove an access control or forget to apply one, or so on and so forth. So that's the real way. That's the best way that we can go about preventing these things from happen, or those 4 steps right there. And of course, they are in increasing complexity based on this first bullet, making sure you first have a well-defined permissions model. Okay. So that takes us through it. That's it. That is taming the perfect storm of access control issues in web applications. If you enjoyed this, I'm now working for OnDefend. I'm going to be teaching my PWAPT class coming up in Q1 of 2026. So get on the mailing list or email me directly, and I can add you to the mailing list if you're interested in that. And you want to take that particular course. It's a lot of content that's just like this, very, very hands-on heavy, learning these types of techniques and so on and so forth. But otherwise, If I can serve you in any other way, please reach out and let me know. Sadly, I won't be able to see any of you at the conference this week because I'm not there, but feel free to reach out to me on Discord if you have any questions, and then continue to reach out to me on Discord into the future if you have any other questions about what we talked about. Okay. Thank you so much for your time.